Welcome dear students. Today's topic is scalars and vectors. We will start with a review of the quantities that we have already discussed. In our last lectures, we have discussed quantities like distance, displacement, speed, velocity, acceleration. We can divide these quantities into two classes. Distance and speed need only magnitude. Displacement, velocity, acceleration along with magnitude, they need direction also. So, there are two classes of physical quantities that we have, and the first class is scalars. Distance and speed are scalars. Displacement, velocity, acceleration are vectors. So, now we start with the definition of scalars. Scalars are those physical quantities that have magnitude only. These are directionless quantities, they do not need direction to describe them. Examples, we already know distance is a scalar, time is a scalar, any length is a scalar, speed, work, energy are also examples of scalars. Now, we will define vectors. Vectors are those physical quantities that have magnitude and direction. Examples of such quantities we already know. Displacement is a vector, it is directed from initial to final position. Velocity is a vector, acceleration is a vector, now we will compare the scalars and vectors. Scalars, vectors. Scalars have magnitude only. Vectors have magnitude as well as direction. scalars change in magnitude only. Vectors change when their magnitude changes, their direction changes, and number 3, when both magnitude and direction change, both magnitude and direction change. Third point is vectors, scalars add following the rules of algebra. Vectors add algebraically. Vectors add geometrically. We use geometry to add vectors. Scalars are represented by simple letters, like we represent mass by m. Vectors are represented by arrow above the letter, that is A with an arrow is A vector. Now, we will discuss various kinds of vectors. First, equal vectors. Two vectors having same magnitude and same direction are called equal vectors. So, we have say vector A, magnitude is say 3 kilometers towards east. Vector V also 3 kilometers and same direction. So, A is equal to B. Both the vectors have same magnitude, same direction. A is equal to B if magnitude of A is equal to magnitude of B and directions are same. If we have in this for equal vectors directions are same, that means the angle between A and B is 0 degree. Now, in case we have the directions magnitudes are equal and directions are opposite, that kind of vectors are known as negatives of each other. Two vectors having same magnitude but opposite direction are called opposite vectors or negative vectors. here we have these vectors A and B. If we change the direction of B to opposite of A, then we can call B vector B is equal to negative of vector A, negative of A vector. So, to for B to be negative of A vector, we should have equal magnitudes and opposite directions. Now, as we have seen here, if we are to show larger vectors of larger magnitudes, then we will have to use some scale representation of a vector. A vector is represented, suppose we have here vector A in the direction south to north and magnitude is 3 kilometers, then what we need is to represent this, we need a scale. We take a scale 1 kilometer is equal to 1 centimeter. So, on this scale this length of 3 centimeters will represent 3 kilometers and direction of A is from tail of the vector to head of the vector. Tail origin is or tail. This point is origin or tail, this is head or terminus, and magnitude of the vector is given by the length of the vector, line. So, this will represent vector A. Unit vector. A unit vector is a vector with magnitude equal to 1. Supposing we have some vector P, it is say 4 kilometers per hour towards east. Unit vector in the direction of P, we can represent this vector by this line. Unit vector in the direction of P is P vector divided by its magnitude 4 here. So, this will be P vector divided by magnitude of P vector. So, this vector will be this vector with unit magnitude and same direction as that of P is P unit vector. So, we have P vector is equal to magnitude of P, magnitude of P we can represent by a simple letter and multiplied with P unit vector. Zero vector or null vector. It is a vector whose magnitude is zero. We know displacement A, displacement vector A is a zero vector. If we have a vector say P, P vector plus 0 vector is P vector, P vector minus 0 vector is again P vector. We will learn later on. If we multiply P vector with scalar 0, then we get a 0 vector. If we add, as we have discussed, B is equal to minus A vector. So, if we add B to A plus B or B plus A is equal to 0. If we take the sum of two opposite vectors, vectors having same magnitude and opposite direction, then we will have a 0 vector as the resultant. Now, with this, now we have certain cutouts for vectors. Let us see with the help of a demonstration what we mean by equal and opposite vectors. Here we have two vectors, they have equal magnitude. You can see one is covering the other. They have equal magnitude, same direction, both are pointing in the same direction. So, these are equal vectors. Similarly, here we have a pair of equal vectors. These are also equal vectors, all of them are having same magnitude. So, this is a group of equal vectors pointing in the same direction. This is another group of equal vectors. This is another group of equal vectors. Now, if I change the direction of one of these vectors to opposite direction, then this pair is negative of each other. This vector is negative of this vector. This vector is negative of this vector. Both are negative of each other. Here these two vectors are negatives of each other. Now, we define collinear vectors. vectors acting along the same direction magnitude may not be equal are called collinear vectors. Vectors acting along the same or opposite direction. Here we have vector P, vector Q, vector S. These are collinear vectors. This kind of vectors that are in the same direction, pointing in the same direction, are parallel anticollinear vectors. These vectors are parallel vectors. If we have vector q is pointing in the opposite direction, then these vectors are known as anti-parallel vectors. As we have seen when we are discussing about displacement, displacement is a vector starting from initial position, ending at the final position, and directed from initial to final position. So, this is the shortest distance travelled by the particle. Now, here the tail of the vector is fixed, tail of the vector is at the initial position. So, this kind of vectors we define as fixed vectors, fixed vectors or localized vectors, are those vectors that have fixed starting point or tail. So, displacement is an example of fixed vectors. Other kind of vectors is free vectors. Vectors that are not fixed are called free vectors. Displacement velocity of a particle is moving along a straight line, its velocity at different points v, let us say here it will be v1, v2, whatever is the value, it can be moved from place to place. here on the diagram we have examples of free vectors, fixed vectors, bound vectors. Tail is fixed. Here tail we can move along the line of action. So, this is a sliding vector where the tail of the vectors can be moved anywhere on the plane, that such vectors are called free vectors. Co-initial vectors. Vectors having common point for the tail, A vector, B vector, C vector are co-initial vectors. Vectors having their tails at one point. So, A, B, C are co-initial vectors. We have co-terminus vectors also. Vectors, terminus vectors are those having common terminus point. So, P, Q, R are the coterminus vectors. Now, one vector that we will be dealing in our next lecture is the resultant vector. When we discussed about displacement, we talked about displacement from A to B, B to C, then net displacement is from A to C. So, we can say displacement AC is equal to displacement AB plus displacement BC. So, vector AC can replace two vectors AB and BC. So, we can call AC as the resultant of these two vectors. Resultant vector is a single vector that can replace two or more vectors without affecting their effect. So, with these definitions, young friends, we end today's lecture, and in the next lecture we will start from here. Thank you.